Hi, everyone, and welcome to ODTUG's online education series. Today's webinar is Property Graphs 101, How to Get Started with Property Graphs on Oracle Database, presented by Arthur Dayton of Vlamis Software Solutions. This presentation will be recorded and available for viewing on the ODTUG website by tomorrow. Please feel free to put your questions in the questions box at any time during the presentation, and they'll be addressed during the Q&A period at the end of the webinar. So welcome, Arthur, and thank you for being here today.
Hi, thanks, Karen. Hello, everyone, and good afternoon, morning, depending on where you are. So today I want to talk about property graphs on the Oracle database, and I really want to approach this from the perspective of folks who probably or maybe have never touched a property graph before and are curious how they could get started and begin to explore this technology on their own. Before I dig in, let me just take a second here and plug Collaborate. So Collaborate's coming up in Orlando here soon. Kscope's coming up here in Orlando soon, and we'll be doing some presentations down there. And so if anybody hasn't had a chance to sign up, I just wanted to take a second to let you know that, Kscope is open. We'll be there doing some presentations. And if you wanted to find me while we were down there, we could talk some more about property graphs or anything else you're interested in. So also, I'll be doing some presentations that Collaborate coming up as well, and so if you happen to be going to either one of those conferences, then feel free to reach out, and I'd love to talk to you. So today, what I really want to talk about is I want to give you a sense of why to care about property graphs, how they're different from maybe what you're used to, especially if you work in a business intelligence realm and are kind of used to relational databases. Property graphs are kind of a different animal, even though we're now able to use a relational database to persist them. And then I want to cover, how I went about getting started with the property graphs, show you how to create them on an Oracle database, and show you really, hopefully, how easy it is. And then we're going to look into some of the technology for visualizing, and I'm going to use Cytoscape today to show you how you can visualize your property graphs. And I think once you begin to visualize them, you get a sense for just how powerful they are, and it really begins to bring into focus how property graphs are different. Then we're going to use a language called PGQL, Property Graph Query Language. This is a SQL-like language that Oracle is working on standardizing with other property graph vendors, and trying to come up with a specification that will be standard across technologies, and then hopefully will eventually be integrated into the SQL standard so that property graphs become a first-class citizen on relational databases, and we can use the same sort of DDL and select statements that we're used to today. And then we'll touch a little bit on using some of the built-in algorithms that come along with the property graph, and seeing what you can do with those. So a little bit about Vlamis. We're headquartered out of Kansas City, Missouri. We have a number of people who are Oracle aces. Dan and Tim have both been authors through Oracle Press, most recently with a data visualization book. And then, of course, we are part of the Oracle University as a partner and the Oracle Gold partner. Myself, I'm a senior consultant with Vlamis Software Solutions. I sit on the Oracle Spatial and Graph SIG as the education chair, and we just got done with the Analytics and Data Summit, which the Spatial and Graph has SIG has a summit there as well, and that was out at the Oracle headquarters. Great conference. Highly encourage people to check that out. It goes on every year out there. It'll be in March of next year as well. So Analytics and Data Summit. I'm an instructor at the University of Nebraska in the Information Systems Quantitative Analysis program. Volunteer with the ODTUG BI community, and if you ever want to find me, I've got my Twitter handle here. You can also find me on LinkedIn, and you can obviously go to Vlamis.com and check out our blog, and you can find some stuff that I've done there. So digging into the graph, obviously here's some slides from Oracle talking about the property graph on the database. One of the reasons the Oracle implementation of property graph is something that is particularly interesting is obviously scalability and performance. It's built on top of the Oracle database. There's also a implementation using the big data technologies as well. And then they are integrating a bunch of built-in analytical functions. I talked about PGQL, and they're continuing to design that. And then very soon, there'll be a number of exciting things coming out on the Oracle Cloud as well, where they'll be rolling out some Oracle property graph functions with the Oracle Cloud that'll make, I think, a lot of this stuff a lot more approachable in the future. So looking forward to that stuff coming down the pike. What are the kind of use cases for graph? There's, I think social media is one of the things that comes up a lot, trying to identify influencers. So if you've ever seen a demonstration on this, you've probably seen something with Twitter where folks are trying to identify like why tweets go viral or what kind of folks have the biggest influence based on their followers and who's retweeting them and all that type of stuff. But it's also very handy for discovering patterns in all sorts of data. So we'll be focusing today on some employee information and showing a relationship between employees, but I saw some very interesting presentations just this last week at the Analytics and Data Summit showing how, for instance, auto manufacturers are using property graphs to be able to understand the relationships between all the parts that go into various cars and the cars themselves, and really being able to optimize their supply chain and being able to standardize some of the parts, selection stuff across models using property graphs. And then also, as a recommendation engine, if we can see that people who have a lot of sort of relationships, if you will, in common with you, we can then infer that you might be interested in some of the things maybe you haven't looked at that they have. So it can also be used, from a recommendation engine standpoint. There's a number of use cases out there. Banks in particular are using property graphs to try to discover fraud. I saw some also great presentations with the Chinese police departments and also some of the large banks in China, where they're really trying to hunt down criminals based on the relationships that they share in common. And also there was a very interesting presentation on tax fraud, being able to follow the money, if you will, through a group of different entities and discover where money laundering and those type of activities were taking place. And then I mentioned that there's a number of manufacturing use cases where people are really analyzing these complex bill of materials and being able to more clearly represent how all the things that go into manufacturing particular vehicles or other products are related. So the property graph model is fundamentally different than what we're used to from a relational perspective. In a when we're modeling things relationally, if you think of things as a star schema, typically where the table is the first class citizen, and then the joins are used to build relationships, so we link tables together by joining various fields. In a property graph, the relationship itself becomes a first class citizen, and that's really what we're modeling. So this kind of opens up the ability for us to create a large number of entities or vertices and express the relationships between them without the vertices or entities having to be of a common type, or the relationships between them having to be of a common type. And I think when we, in just a minute here, take a look at how the graph is persisted on the database, this will become clearer. But instead of having very wide tables where we store a number of columns of information, in the property graph we really have very narrow tables, and we're able to store different types of data all in a very narrow table. And that'll become pretty clear here when we open it up and take a look at how we create a property graph on the database. So, looking at the difference between the relational and graph model, and just kind of building on what I just said, we're kind of used to expressing relationships with a relational model by joining many different tables together, whereas in a graph model, we merely just express the relationships between these different entities. And the best way to understand this, in my mind, is to actually look at it. So I won't spend too much more time on it here, because it'll be, I think, easier to understand once we actually look at it. As far as the architecture of property graph on the database, or using the big data, obviously from a persistence standpoint, there's a number of different ways. What we're interested in today is we're able to persist our graphs on the database, but you could also be using HBase or the Oracle NoSQL database to persist this. And then there's a graph data access layer that's present that really abstracts storing and sort of all of the functions between moving data back and forth from the storage layer, and being able to access that through a number of different languages. I'll talk a little bit today. We can access the graphs through SQL. We can use Groovy. We can use Java. We can use PGQL, which we'll be talking about today. You can also use Python. So there's a number of different ways to get at this graph data, and that data access layer really abstracts that so that all the various APIs can get at the data. Ultimately, we see here we'll be visualizing with Cytoscape, and there's a number of other commercial technologies out there for visualizing graph data. What's nice about Cytoscape is it's open source, so free to use as you are getting started. And then, if you mature your graph, if you kind of move up the maturity level of your graph implementation over time, some of those other visualization technologies may appeal to you. But as far as getting started, Cytoscape is great for that. From a format perspective, I don't really feel a giant need to dig too deeply into this, but basically all the standard flavors of property graph formats are supported with the Oracle implementation. So there's lots of ways to get the data both in and out of the storage layer if you want to, move it, or you're going to be importing it from somewhere else. What I'm going to focus on today is really using SQL, because I think a lot of folks, if they're particularly interested in the database, are going to be interested in how do I get information that's in relational tables into a property graph and then be able to utilize that. If you have graph data coming from other places, then obviously flat files are an easy way to move that data around, and we can talk about that a little bit if somebody's interested. But today I'm going to focus pretty much on the SQL-based approach. So what's so powerful about PGQL is when we begin, property graphs are really an exercise in sort of recursion, right? Because we're looking at the relationships between multiple entities or vertexes, and those relationships may be very, very deep, have many, many layers. And when you begin to try and write relational SQL to express those relationships as they get more complex, the SQL would become a nightmare. But PGQL gives us a means for expressing our queries in a way that really talks about the relationship between the data as opposed to the physical joins necessary to bring back the data. So we'll take a look at some of this with what I'm going to demonstrate to you guys today, and then if anyone has some questions, we can dig a little deeper into that. One of the things I want to point out here is there's the PGQL specification. If you go look at pgql-lang.org, you'll find the various specs that are available out there right now. The specification is moving along, and they're adding a lot of functionality to it, and I'm looking forward to when we can get to the next versions. But if you're digging in and you are trying to wrap your head around PGQL, which if you're used to writing SQL will be a bit of a different animal, the specification is very helpful because they give a number of examples and kind of make it a lot easier for you to find your way. So you can go look that up on the web, and you can find all sorts of information about PGQL out there. So let's dig in then. I'm gonna get rid of my presentation here, and we're gonna log into a VM that I have here that has all of my my database and my property graph information on it. So give me just a second to get that fired up. Naturally, it fell asleep while I was talking. Okay, so what I've got here is just kind of a standard Linux, Oracle Linux desktop, and I've got this sitting out on the Oracle Cloud infrastructure as a service, and I am using the 12.2 version of the database, which I have installed on this machine. The 18C version is also available, although only through the Oracle Cloud at the moment. You can't install that on-prem, and it also has some pretty exciting enhancements in it. But I haven't gotten far enough along with the 18C stuff to feel kind of comfortable showing it to you today. So we're going to use the 12.2 version of the database. And I'll talk a little bit about some of the enhancements that are in 18 as we move along today. But for the most part, if you're just getting started, the 12.2 version is going to be just fine. And I think as they enhance it and we move along, obviously the 18C version is going to have a lot more functionality. But for those of you just getting off the ground, 12.2 is going to be perfectly fine. So as far as what we've got running on here, I've got a number of different programs I'll show you. So first, let's just start off with the stuff I'm not going to talk very much about. It is perfectly possible and very well documented to use Java to populate your property graphs, and I've gotten a simple example, and I've put a blog post out there about this. You can use, I think maybe what have we got, 115 lines of code, and you can create property graphs, using data from a SQL data store or a file-based data store, and this will create property graphs on the Oracle database for you. And this is convenient. The Java API is very well documented in the Oracle documentation, but If you're a database person, then Java is probably not the most attractive thing to you. And I can remember exactly my boss's reaction to this when I showed him, hey, here's how we load this up using Java. He's like, why do we got to use Java? This is, I want to use a database. Why can't we use SQL? And the fact of the matter is that you can use SQL. I just want you to be aware that there's a number of different approaches, Java being one of them. And if you're more comfortable in Java than SQL, then know that you can take that approach. So I'm going to leave that there because what I'm really interested in is creating a property graph using sort of standard SQL, which I'm used to, because I work in business intelligence analytics and spend a lot of time with databases. SQL developer is really going to be my preferred place to live, especially if I'm utilizing data that's already on the database and just want to transform it into a property graph. So if we take a look at, okay, how hard is it to create a property graph? It's actually remarkably simple, right? There's this create statement, create property graph statement, which is documented in the property graph manual that comes with the database, and I'll just pull that up for you guys here quick. If you go out and look for the Oracle database documentation, look at the property graph developers guide, everything I'll be showing you today is going to be contained in there. So there's lots of stuff out there. So creating a property graph is as easy as just executing this PL SQL statement, and I've already run this. I've got this HOL property graph, which is a property graph I used for a hands-on lab we did out at the Analytics and Data Summit. And essentially, you just say, you give it the name of the graph, some parameters around parallelism and partitioning, the table space that you would like this thing to be created in, and that's all there is to it. And what happens after you create a property graph on the database is it creates a set of 4 tables. And if you take a look over here on the left-hand side, actually 5 tables, excuse me, you can see the tables that were created as a result of me executing this statement. So the only 2 tables that are really relevant to us for the time being are going to be this VT table and this GE table. So all new property graphs, if you look, I've got several of them here, are going to be, all the tables that are created are going to be suffixed by these VT, GE, and these other suffixes you see, and then they're going to be prefixed by the name that you actually give your property graph. And if we take a look at these tables, you can see that I've already populated some, but this is where we get into what I was talking about with the tables being very narrow. And the way this is accomplished, the way that we can store all sorts of different data types is there are several columns that are used for different data types, and then there's a flag that essentially tells the system what type of data type it is. So if you take a look right here, this T column I have, this has a data type of 1, which correlates with a string. And then this V is the column that's used to store all of our string values. The VN is using for storing numeric values, and I don't have any in this particular property graph, but the VT column is used for storing date columns. So and then, you can see obviously down here where I've got some numerical stuff that I've stored both in text and numerical format that I've called it out as a different data type, and that's how the system knows what kind of data type it's actually dealing with. So we have a series of columns, and every graph table will look exactly the same as this graph table here looks. And then the data types are called out by this flag, and this is kind of a NoSQL approach to storing key values, which is what we're doing inside of a property graph. So then the other thing that you can see here in this table is we have this VID field, which is where we store our vertex IDs. And then we have the properties that we're going to store in our graph. So for each vertex ID, I can have multiple properties, and you can see here that I've got some job title information, some manager name information, some salary information, and then all of this information can be included in our graph. So this table, this VT table, defines the vertexes or nodes or entities that will be in our graph. And then the GE table ultimately stores the relationships between those vertexes. So here, what you'll see is we have this EID number, which represents the unique identifier of an edge or the relationship between two vertexes. And then we have the source VID and the destination VID, which is a reference to this VID column inside of the VT table. So that's how the property graph models the relationships between our various vertexes. And then these relationships can have what's called labels. So we'll see here in just a second that when we're expressing relationships between employees, we can have manage or employee or all sorts of different things. And then you can also store properties for your edges as well. So what's one of the cool parts about this is we can have various properties for various vertexes, but they don't need to be the same. And then the same goes for the edges. So we can store all sorts of information and be able to traverse relationships between entities without having to sort of conform anything other than the relationship itself across the entities. So, okay, that's a long explanation of the table structure, but hopefully that gives you a little bit of sense of how the property graph schemas are different from a typical relational setup. As far as actually getting data into a property graph, you can see here that I've run my PL SQL statement to create the property graph. I have my tables created over here on the side. And then once these tables are created, I can feel free to, put data into them and take data out. That's no big deal. You don't need to recreate your graph every time. So you can sort of iteratively explore inserting different types of vertexes and the relationships and properties. And then if it didn't go quite the way you wanted, you can just trunk the data back out of there and start over. So as far as adding data, we can use a simple select statement, and it really just requires you understanding the structure of the table. Here you can see I've got my vertex table. I want to insert some employees into it. So I need to give it, each vertex a unique ID, which I'm creating with just a little bit of concatenation here off of the employee ID. I give it a property key value, which I'm calling ename here. I give it the data type, which is 1, which corresponds with a string. And then ultimately I stick the string value in there, which is the employee name. And then I have a vertex created by inserting that information in there. And then I can do the same thing I can then create an edge or relationship between various employees by indicating that there's a relationship between managers and employees. So if you take a look at this one, I've just created another unique ID for my edge table, and then I've referenced the manager ID from the vertex table and the employee ID and express the fact that there is a relationship between them, and then given that a property of the manager name. And then once I commit that to my tables, I'm ready to actually visualize that information in the property graph. And so from there on, and we'll jump over to Cytoscape here quickly, but from there on, it's really just an exercise in adding additional information. So one of the things that I do is I go through in order to make my property graph a little easier to query, I add a node type, and I can identify nodes as either managers or employees, and we'll see expressly how that works here pretty quickly. And then we can add all sorts of other properties. And one of the convenient things about a property graph is that all of this information kind of exists in different places, and I'm able to bring it all together inside of the property graph and then, traverse the various properties and relationships without having to join together, tens or maybe even hundreds in the extreme scenario of relational tables in order to do some interesting queries on it. Ultimately, what I end up doing as well here, you can see I've added job title, I've added min and max salaries, and an expression of how close somebody is to their maximum salary. And then we're also able to add department nodes, and this is where we get into creating vertexes that are different. We started off with employees, and then we ultimately create some department nodes, and I can really add any vertexes I want in here, and then just ultimately express a relationship between the vertex, any vertex and another vertex. So here you can see I've got this edge for department relation, and then this is where I establish the relationship between employees and their departments. And we'll take a look at that here in just a second. And then lastly, you can see right here, I've just got all commented out. I'm not quite sure how well you guys can see this, but we've got just the various data types that you're able to put into the property graph. So we've got string, integer, floats, doubles, dates, and Boolean values. And you can also, it also supports some spatial data as well, but I'm not going to dig into that today. So, okay, I've talked a whole bunch about how you get data in here and shown you a bunch of insert statements, and none of that is kind of particularly exciting, but you can see, hey, we've obviously gotten the data into the table. We've created, many hundreds of vertexes here, and then we've created the relationship between those vertexes. What does it all mean? What do we do with this information? And that's really where the visualization component comes in handy. So, Oracle has a plugin for Cytoscape, and you can go out there and find that on OTN, and graph the blog I've done about this also points to it. Essentially, you just need to put some files in different places for Cytoscape, and then you have a plugin to actually load property graph data from the Oracle database. So you can see here I've got this load property graph and connect to Oracle database. If you just download Cytoscape and install it, you will not have this option. You need to put the plugin that Oracle provides so that you can actually do what I'm going to show you here. Now, once you pull this up, there's a number of different options for getting data out of the Oracle database. So probably the easiest way to get started, you can see I've got to my URL and all of that connection information, which there's actually a config file where you enter this. Easiest way to get started a lot of times is just select some random vertices. So here I'm just using the Scott Tiger standard example user. And once I put my password in, I should be able to take a look at all of the graphs that I have created inside of the database. And you can see I've got a nice little garbage pile of different graphs I've created. But here's this hands-on lab property graph that we were talking about. And so I can select that graph, and if I wanted to, I could just say, hey, let's just start from 10 random vertices and see what comes out, right? So if I go ahead and click that, it's going to execute this against the database, and then it's going to come back with a list of 10 random vertices out of here, which if we take a look at these aren't particularly expressive because they're just showing this sort of default label. But we can then, because of the plugin, come in here and say, hey, I want to use that ename property that I put into the property graph as the label for these vertices, so I can have a little clearer idea of what it is I'm looking at here. So if I do that now, we'll see that I've actually pulled back a list of 10 random vertices, and these all just happen to be, or at least it looks like they all happen to be, well, most of them are just department vertices, but here you can see we've also got a manager vertex as well. And then we can just start to explore our property graph. So one of the interesting things you can do inside of Cytoscape at this point is we can begin to expand the relationships here. So if I were to select this marketing, I can actually say, hey, go ahead and expand the vertices, and it will pull back all of the vertices that marketing has a relationship with. Now, by default, it just kind of stacks them all on top of each other, so we need to use a layout. So if I just use kind of a simple circular layout here, we'll see that it pulled back both an employee and a manager here, and we can obviously drag these things around and whatnot, but those are kind of two of the vertices that have a relationship with this marketing vertex as well. And we could try this on some of our different vertexes and expand out, and we'll see that we get you know, some more information as we drill into some of these different nodes. So I'll just use our circular layout again. We can see here that, hey, Stephen King, our manager here, you know, obviously has a lot on his plate, because here's all these various folks that he manages. And then we can see that, you know, he's obviously managing the manager of the marketing department. And then if we drill down actually on some of the other nodes here, we would see that, you know, what we're probably looking at is somebody in charge here, because we'll see that when we express this layout, we'll see that, hey, some of the people that Stephen is managing are themselves managing people. And so we begin to get a sense of how the property graph can begin to express multiple relationships between multiple entities. Also interesting here, if we take a look, we can see that Stephen King is the manager of the executive department, and then he's managing Nina here, who is an employee of the executive department. So that begins to show us how we can express multiple different types of relationships between multiple vertices, and begin to really get a sense of you know, exposing relationships that might not be quite as easy to see if we're just using straight kind of SQL on these underlying tables. Now, this particular graph is kind of simple by design so that we can understand it, but then, you know, we can expand on this and begin to really add, you know, millions of various relationships between all sorts of disparate vertices, and begin to parse out, you know, some you know, kind of what's interesting about those relationships using the property graph. Now, loading the property graph up this way is great. You know, it's an easy way to get started. We just went in here and loaded up some random vertices, but it doesn't really express the power of what you can do with the PGQL and some of the other approaches. You know, just to let you know here, we could start off with utilizing a built-in analytical function to populate our graphs, so we could go search for our you know, highest rank graphs. We can also do our highest ranked vertices. We can also look for information, or we can start with you know, a key value search. So if I come into this panel here, we take a look at our various graphs, and now I should be able to search for the different properties that are available to me. So, you know, for instance, if I wanted to start with the node type property and I wanted to look for department node types, and let's just see if I can properly remember how I put this in here. You'll see that it says, hey, looking at this key value pair that you give me, I see that there are 11 department nodes out there, and if we wanted to, we can go ahead and just load those up as well, or load those up in a new graph here. And here's our various departments, and you know, we can come in here and then choose a label for this so we can, you know, actually understand what we're looking at here. So there's the 11 departments that we were able to find using the key value search to populate our graph. So the approach that I particularly like for loading the graph is using the PGQL language. And this is where we begin to get into the power of PGQL. So I'm going to go ahead and put my password in again. And we're going to choose this hands-on lab. And now here we see our first sort of piece of PGQL. And this is where you know, you kind of have to get used to how this is significantly different from standard SQL as we're used to. So you can see here I've got this select NET, which is really just referencing some arbitrary variable declarations that I've made here in the where clause. So the way that PGQL works is using these parens here, we express nodes, and then we have a dash E, square brackets E, and the square brackets are used to denote edges. And then we're saying, hey, where there is an edge in this direction, you can see we've got an arrow pointing at this other node in parens here, and then we're going to limit the result set to 10 results in case we happen to ask for, you know, 40 million nodes that way. This is just kind of an easy way to get started. So really what we're saying is we would like to return a set of nodes and edges where the node type of the beginning node is manager and there is an edge going to any other node. So in order to do that, we just use this PGQL here, and we can go ahead and execute this query against the PGX server that's included as a part of the database. And now we can see, if we switch our labels again, that we have actually returned, you know, kind of randomly, a number of managers, and we're seeing the various nodes that are related to them. So, you know, John Russell is managing these various people, and here's a number of other people that have a managed relationship with somebody else. Now, because we put the limit on it, it doesn't really you know, expresses a little bit randomly because we're not really giving PGQL or Cytoscape the ability to build out the complete graph. Now, because you know, we happen to know that that this graph is of a manageable size, it's all right to do what is, you know, in effect the equivalent of select star from, you know, some random table that I have no idea how large it is. Now, I know in this case that it's not particularly large, so we can come out here and say, hey, why don't you give us all nodes and vertices for this particular graph, and let's put those on the display. And so this query will take a second longer, but not too much. And now you can see, hey, oh, we've got quite a bit more complex graph here, right? Or we've got a great deal more information. Now, I can come out here again, and if I click over here in our white space, I can change our labels so that it's a little more meaningful. Now we can see essentially, hey, we've got departments and employees and all sorts of stuff like that. It's a bit of a jumbled mess the way that it renders by default, but then we have this ability to use all these various layouts in order to create a different kind of layout. So we could, try a radio layout, and, we can see there's all sorts of different ways to lay out this information in a way that makes it a little bit more understandable. So here we can say we've got Stephen King, who clearly must be the big boss, and then all the various managers that report to him, and then all the people that in turn report to them. And then one of the other things that we can actually show when we come out here is we can look at the properties that we've put on here. So if I look at show properties, I can also take a look here and see all these properties that are associated with this particular vertex. His title is president, unsurprisingly, given the way that our graph has come out here. And then, we can see the max and min salary and the percent of his max salary that he has, and all this information that we've chose to make a property of these vertices on this graph. So, okay, just quickly taking another look at the things that we can do and how we can then make this a little more expressive. I can come in here and say, I would like to see all of the nodes with a node type that is equal to manager, and then I would like to only see the nodes that also have a node type of manager, so people who report to our manager here, and then we can express that relation. And this is where we begin to be able to really express pretty complex relational queries in very simple terms as we begin to understand how to write PGQL. So if I go ahead and, presuming of course I haven't messed up my syntax here, and execute that query, then I should get returned a graph that shows me really managers that are reporting to managers. And then we can obviously come out and put our labels in again and get a sense of who we're looking at. So obviously with the visualization component, this is where we really get a sense of what the property graph can do. So if we were to come out here and just express our plain graph again here, and bring everybody in. There's a number of different layouts that we could use to kind of bring clarity to the information that we're returning. So if I bring back the complete employee graph again, and then I use a hierarchical layout, then or a tree layout, I should get something that very much looks like a like a typical employee chart where we express the hierarchy of the organization. And then I can come in here, show our labels again, and we can see, hey, we've got Stephen King at the top of the stack here, and then here's how our organization kind of lays out top to bottom. And so that ability to express and visualize these relationships is very powerful, and what I think is particularly intriguing about this. Now, the other thing we can do is actually use Cytoscape to utilize some of the built-in analytics functions. So we can actually use this label propagation, which gives us basically a clustering algorithm. And so what we've done now is actually been able to detect relationships between all of these various vertices using the analytical functions. Now, we happen to know, looking at this data, that we have departments, right? So the clusters that we detect using this type of information may not be particularly surprising, because we are detecting the departmental relationship between all of these employees. But the point here is to show the ability of the technology to determine these clusters for you. And as you get into graphs where the known nature of the relationships isn't there, this clustering then becomes a very powerful analytic functionality, because we can then begin to discover the relationships between various nodes by using some of this built-in functionality. So I've kind of jogged through quite a bit of stuff here in 50 minutes, and hopefully given you a sense of how to get data into a property graph on the Oracle database, and then some of the things that you can do with a Cytoscape visualization component. I see that there's been a number of queries rolling, or a number of questions rolling in, and it looks like they're being answered as we're going along here. But just and hopefully everybody can see those. But obviously there's a number of questions about how indexes are created, and you can actually use the Oracle text indexing within the database to make it kind of even more powerful, the way that you can search over top of the property graph information. I also see that folks have asked a little bit about how the CRUD operations are done. You can obviously see here that we're using SQL to get information in and out of the property graphs. Now, in 18.1, which is particularly interesting, they've actually introduced the capacity to translate PGQL into SQL statements. So one of the things that can be a little bit challenging if you want to build an application around this stuff is a lot of our applications may be very used to kind of speaking SQL. So creating, being able to sort of natively create PGQL and then submit that and get the result sets back from the server, may be something that isn't going to fit your use case. So there is actually the ability in 18.1 to translate the information, translate these PGQL statements into SQL directly. And, I think that may be a very interesting use case for folks who are trying to build property graph analytics inside of other applications that are probably a lot more comfortable using SQL as their primary means of data fetching. So I guess with that, I'd like to open it up and see if there are any other questions that we can answer for folks. And then I also wanted to offer that I will put this example out in the public domain. So if you're interested in creating this particular example on your own Oracle database, I'll give you the stuff you need to do it, so that you can go out there and play with this stuff yourself. I have put out a blog post where I've shown how to create this utilizing the Java-based approach, but I'll go ahead and also create another blog post here where we put the SQL-based approach out there, and then I think for a lot of folks, you're going to have some very interesting data on your databases that will, obviously, using standard SQL, be a lot easier for you to get into the graphs that way. I see a question out there about open source, what's open, what's closed. Obviously, Spatial and Graph is a pay-for option on the Oracle database. And in the past, with a lot of the pay-for options for Oracle database, it kind of could be a barrier of entry for a lot of folks, because typically you might have a very large data warehouse instance on site, and the idea of licensing, one of these pay-for options just to try something else out could be very daunting if you have an 8 or 16 or 32 proc box. Obviously, if you understand Oracle licensing, that's going to be pretty expensive. The great part about the cloud paradigm today, and what's particularly wonderful about it, is you can go out and get a database from the Oracle Cloud that is fully baked with all the licensing you need to run this type of stuff, and run it for, you know, a few dollars an hour, and not have to be concerned about getting in trouble with, you know, your Oracle licensing, or for that matter, having to go through all the pain and suffering of you know, building out all the infrastructure and having to go through sort of the purchasing, you know, pain that you would have to go through to POC something where you might need tens of thousands of dollars to get off the line. You know, I've gone out and gotten 18C version of the database up and running using a cloud account, and in fact, Oracle will give you $300 credit any day of the week. You can sign up for 30 days, and you can go out and do this complete example for essentially free with a trial cloud account. And then, you know, if you want to you know, keep moving along with the property graph stuff in the future, you know, you can measure your incremental cost in dollars per hour, as opposed to you know, the typical on-prem approach. The Cytoscape, Eclipse, the other stuff that I've shown you today is open source. Obviously, the property graph technology itself is proprietary to Oracle, but the cloud paradigm gives us a much easier way to approach this. Now, I see a question out there too about where does PGX execute, inside or outside of the database. It is, although it lives within the database file system, if you will, I've actually just created a script on here to fire this thing up to start the PGX server. It doesn't necessarily have to live on the database, it just happens to be there. And then that fires up, you know, inside of a shell and just goes along and, you know, runs. You can see all the logging stuff going on there. But that's it runs independent of the database, and it you know, kind of consumes memory independent of the database. So there may be scenarios where you want to run that off the machine. But for you know, for a sample startup, you know, this particular machine right here is like a 2-processor, 14 gig of RAM database, and you know, it does pretty well for, you know, smaller graphs. I think obviously if you're going to get into, you know, larger graphs, you know, stuff in the maybe hundreds of thousands or millions of rows, you'll want to move up the chain. But again, I think the cloud paradigm makes that quite a bit easier, because you can, you know, resize your database nodes kind of at will on the Oracle Cloud without having to go through very much pain whatsoever, which is, you know, probably a lot easier than the on-prem approach as well. So that brings us to the end of our hour. If you want to reach out to me on Twitter or through LinkedIn or anything like that, I'm happy to share more information. We've really just touched the surface of getting into this property graph stuff, but I think for a lot of folks out there, you want to know how to get started, and hopefully I've given you a sense that it's easy and given you a hint of how to get out there. And I'll be sure putting out information that will document everything I've done here. So if you want to try this yourself, you can get out there and do it. I hope you found this interesting and helpful. Please feel free to reach out. And, you know, if anybody does go out there and try some stuff with the property graph, I'd love to hear about it. I'd love to hear about the use cases, because I'm very fascinated by this technology, and love to hear about what people are doing with it. So please reach out. So with that, I'm going to go ahead and I guess end the webinar. Please feel free to reach out, like I said, and hopefully we'll have a chance to talk to you some more in the future.
Thanks so much for being with us today, Arthur. And thank you all for attending. Have a good rest of your day.